Hey, what's up guys, Jeremy here. If your favorite collaborative robot isn't part of our robot library, you can create it yourself from scratch. You only need to grab the 3D model and the datasheet of the robot and you're ready to go. Let's do that together. For this video, we will recreate the cobot CR10. Currently, it isn't part of our library. The CR5 is, but the CR10 isn't. That will be updated before this video is released, but let's say that you are facing a situation like this one. If we open RoboDK, we can go to Utilities, Model Mechanism or Robot. On the left, you can see all the possible mechanisms you can create. For this example, we want to create the 6-axis collaborative robot, or cobot. If we look at the window here, we have an image of the robot with some measurements, a place to enter the measurements here. We also have the name of the robot, and here we can select our robot 3D models. As you can see, there's 7 drop-down menus, so we'll need the robot as 7 independent pieces or objects. Okay, let's close that window. First, you need to gather some information. We need a 3D model. So some brand will provide the 3D models of the robot directly on their website. Second thing you need is some sort of datasheet of the robot. In this case, I can find it directly on cobot's website. If I go to Industrial and CR10, I can find all the info I need. Here I need the robot measurements. I can get all of that from the 2D sketch, so that's great. And if we go down, we can also gather other cool information like the TCP maximum speed, joint ranges, so each individual joint range of motion, and the speed of each joints. Now we have everything we need to get started, so let's go back to RoboDK. First we need to import the robot 3D model. If we open the right folder, we can simply drag and drop it to RoboDK. You can use different file format. I personally prefer using step files. You can also use IGES or STL. Now that the raw 3D model is loaded, I need to make sure the position of the model origin matches with the reference frame shown in the robot builder image, so just this image here. I can see the 3D model origin by right-clicking the robot and activating Visible Object Reference. In this example, the 3D model does line up with the reference image here, so in this case we're good to go. In the contrary, there's another video on the topic of how to prepare your 3D model for the robot creation process, so you should really take a look at it. Alternatively, you can also create a new reference frame where the robot base should be, and simply select that reference frame later in the robot builder window. Now we need to add a reference frame to our station. I'll call it frame robot, and we can drag and drop the robot on it. The next step is to split the robot in multiple pieces. I'll create another video regarding that specific topic, and in the meantime, I just want to tell you that you can right-click any geometry and select Split Object to ungroup a step file, delete, or regroup part of it, just like we have here. Let's open a new station where that split is already done. Now we can start filling the robot builder form, so utilities, model mechanism or robot. Okay, let's give the robot a name. In this case, cobot CR10. Next, select the reference frame you want according to the image here. In this case, I'll select my frame robot. If the robot pieces are sorted from base to J6 in your station 3, all the drop-down menus will be automatically populated, so that's cool. Otherwise, you can select them manually, so that's not an issue. Next, you need to enter the robot measurements. We got those from the website, so let's bring that up. Let's start with the vertical measurements. V1 is the distance between the flat part of the robot and J2's axis, so 176.5 millimeters. A3 is from J2 to J3, so 607 millimeters. A4 from J3 to J4, so 568 millimeters. Let's enter that. And D5 from J4 to J6, 125 millimeters. Okay, now that we're done in this direction, let's go for D4. This one is just a bit trickier. D4 is the distance between axis 1 and axis 5. According to the 2D sketch, that means 193 millimeters in this direction minus 127 in that direction plus 125 in this direction. So all of that for a total of 191 millimeters. Okay, let's enter that. The last measurement we need is D6. So between J5 and the flange, 108.4 millimeters. Okay, that's perfect. Now we can click update to make sure everything is right. You can use the robot panel on the right to jog each joint separately. So make sure all the joints' rotation axes are aligned with the 3D model. If the joint rotates offset, this means that one of the measurements you entered was wrong. So that's a possible issue. So we have a few steps left to do. Let's start by limiting the joint motion. According to the datasheet, all joints should rotate 360 degrees in each direction, except for J3, who can only do 160 degrees in each direction. So let's fill that out. I'm using Ctrl-C and then Ctrl-V to speed up the process, so copy and paste, copy and paste, copy and paste. Okay. Good. Okay, that's cool. Now I can update. You should see the modification reflected in the robot panel joint limits. So the limitation you entered in your builder should appear here in the robot panel. We have now one last thing to do here. We could set the home position. This can also be done later from the robot panel parameters window, but why not doing it already? So for this robot, I think the best home position would look a bit like this. -90 for J3, 90 for J4, and 90 also for J5. Okay, yes, that looks good. So let's enter these values in the robot builder and press update. Okay, now we have our robot. Excellent. In another video, I will show you how to modify the robot colors so that it closely matches the real robot, just like the example we have here. There's also a video regarding joint sense, built joints, and the delta theta parameters we have. That one is also worth the watch. I hope you enjoyed it. If you did, go ahead and leave a like. If you have any technical questions, visit our online forum. Our team will be happy to help you. In any case, have a great day, guys.